So for example 7, here we're going to have a rational function with a slant asymptote. Notice that your degree on top is 1 more than your degree on bottom. So what we should do is we should probably simplify if you can. Well, we try to simplify, you can't factor anything. So let's look for our y-intercept. Your y-intercept is found by finding f of 0. So you plug a 0 in for x. So if you do that on top, you just get a 1. If you do that on the bottom, you get a 1 over 0. 1 over 0 is undefined, so what that means is there is no y-intercept. What? How can that be? Well, think about it. Maybe you'll get it when we come to the point. Let's find our zeros. So let's find your zeros of your function, and that's where you just set your numerator. 3x squared plus 1 equals 0. So you subtract 1. Get 3x squared equals negative 1. Divide by 3, you get x squared equals a negative 1/3. And if we're going to take a square root of something, yeah, okay, square of a negative number, not going to happen. So we also have no zeros. What is going on here? I don't know. Let's just keep plugging along anyway. I mean, I can't imagine I'm doing this wrong. Vertical asymptotes, that is where you take your denominator and set that equals 0. So we're going to set x equal to 0. Yes, x equals 0. Finally, we have something we can graph. So, going back to the question I posed earlier about why in the world don't we have a y-intercept, well, if you have a vertical asymptote on your y-axis, you're probably not going to have a y-intercept. Ding, ding, ding. Makes sense. Horizontal asymptote. Well, n is greater than m, so there's no horizontal asymptote. So that must mean that we have a slant asymptote. The way to find your slant asymptote is to take 3x squared divided by x plus 1 over x. And if we simplify this, this just gives us a 3x plus a 1 over x. In this case, your 1 over x basically behaves as a, this is your remainder. Okay, right here, this is your remainder. So if that's the remainder, that must mean that this is our equation. So our equation for our slant asymptote must be a line. That line is y equals 3x. So if we start at 0, up 3 over 1, up 3 over 1, down 3, back 1, down 3, back 1, you get a horizontal asymptote that looks like this. So now we need to figure out some points that we can plot. So let's plot some points to the left of our vertical asymptote and some to the right of our vertical asymptote. So let's plug in -2 and a -1. Let's plug in a 1 and a 2. So if you plug a -2 in here, you get 3 times -2 squared, that's 12, plus 1 is 13, over -2. So 13 over -2 is a -6.5. So you go back 2, down 6.5. Just inside. Plug a -1 in, you get a 4 over, you get a 4 over -1, which is going to give you a -4. So -4. So you go back 1, down 4. So here's what your graph looks like on the bottom. This is going to go up, it's going to go through here, and it's going to eventually turn back down somewhere and go back down along your asymptote, or along your vertical asymptote. To find out really how far this goes up, you're going to plug in a bunch of points. So we're just sketching, getting an idea of what our graph looks like. You don't have to be super exact. So let's plug a 1 in and plug a 2. So plug a 1 in, you get 3 plus 1 is 4. Divided by 1 is a 4. So over 1 up 4. My guess is if we plug in a 2, we're probably going to get 6.5. Yeah, I would be right. So this graph is going to be coming down along your slant asymptote. Somewhere it's going to turn back up and go along your vertical asymptote. Notice your graph doesn't cross your x-axis, so that's why you don't have any zeros. It does not touch your y-axis, so you can't have a y-intercept. There is your function with a slant asymptote.